Hi everyone, welcome back to this next talk on innovation space on Cegal Labs. My name is Hilde Håland. I work for Cegal. I'm a geophysicist by background, and I work as a senior geophysicist / data scientist in Cegal now. So I thought I'd just set the stage first off with a small talk about what is innovation really. So I grabbed some quotes here. You have to start with Obama. So according to Obama, innovation is the creation of something that improves the way we live our lives. It's a bit lofty. UK Department of Innovation and Skill said the same. Innovation is the successful exploitation of new ideas. And this sounds, super good. But what is it really? The government of New Zealand, they kind of makes it a bit more tangible for us. Innovation is the creation, development, and implementation of a new product, process, or service with the aim of improving efficiency, effectiveness, or competitive advantage. At least for me, that's a bit more easy to relate to. So what is it that we kind of, or why am I bothering talking about this? I feel like this is a good introduction to what it is that we try to do or aim to achieve with innovation space that we'll talk about today. Because what we really want to do with innovation space is to set the stage for innovation for our customers. So innovation space in all practicality is basically a separate IT environment or separate IT environment areas where innovation teams can test new software and create new services without being part of an IT change regime. So as it has been mentioned before, and as most of you probably know, Cegal, we offer, for example, GeoCloud, a comprehensive IT environment where we set up and handle your applications and your data. And when you have a setup like that, it's great in the way that you as a customer don't really need to worry that much about how your system is set up. But it also means that we as the provider need to have some fairly strict and maybe sometimes cumbersome pathways to get from a testing stage to where we can roll out software to everyone in the organization. And this is due to wanting to keep a system stable and wanting to keep it safe for all users. And while that is great for organization as a whole, if you are a R&D team or if you're working with trying to kind of create new solutions and test them out quickly, it's not the best way to work. And what we're seeing is that rapidly changing business needs and focus on improving data quality requires that we have a new way of managing data so that we can allow for kind of creating this quick value to the business. We need to allow or create a space where we allow you as users to easily test out, maybe prototype, and see if a solution can bring value to you. So as part of that, this innovation space setup, we've also created something called Cegal Data Labs, which is a centralized hub for collaborative data science and data management. Again, it's a little bit lofty. We'll get more into the kind of the tangible part of this in a little short while. But basically what we're trying to do is we're trying to set up an environment where it's easy to innovate and easy to collaborate. Cegal Data Labs in particular is a way to help create quick value by creating small MVPs, short programs or applications that can solve problems at hand. If we go a little step back to innovation space, the power of innovation space is that we can basically tailor this to be whatever our customer needs it to be. We look at the client's needs and their requirements for a setup, and we can create an innovative setup that fits those needs and requirements. The main target of this setup is then to assure high connectivity and data flow between use cases, teams, regions. If you're sitting with an R&D team in Houston and an R&D team in Norway, you want it to be easy to pass data back and forth, not necessarily having to send data over an FTP, but assure that everyone has access to what they need to have access to, and that you can easily share whatever solutions you come up with. We want to enable data science workflows on company data. That might not seem like a big deal, but for those of you who have done a bit of data science, particularly with a VDI setup, you might have realized that running your own code in kind of a strict IT regime is not the easiest. And it's also not very easy to get data out of your VDI setup to run it on a local machine. So that's where we want to kind of enable you to be able to do that by creating a space where you can both have your data and the ability to create these data science workflows. As a kind of tail on to this, but which is also quite an important point, is that this also facilitates exit strategies from legacy software. So by allowing you to test and create, you can also then more easily decide what legacy software can I actually avoid using here to alleviate pain points in whatever workflow I'm working with or in. To get a little bit into the nitty-gritty of what innovation space is, this is an example. I'll step through this a bit in detail because it's a bit confusing maybe from the get-go. Innovation space as a thing is not really. I mean, it's not a product, out of the box product that fits all. Innovation space is a setup. So if a client comes to us and wants to have an innovation space set up to do all of this testing and prototyping and whatever they want to use it for, as we've discussed previously, we would start by first identifying the customer's needs. What are they looking for? What are they wanting to get out of this? And then we would start by setting up a system that then tailors to that. So innovation space could consist of, for example, a GeoCloud, a separate GeoCloud setup, a test environment setup where you can test third-party applications. So say you have, you have a product coming in from a vendor, you want to test it easily without rolling it out to your entire organization. You can test it in a test setup of a GeoCloud. We can quickly implement Microsoft products. So you can set up a Power BI service or whatever you want. Test it easily, see how it works, connect it to your data that you have available on your VDI system, on GeoCloud, in whatever cloud vendor you choose to use. We can set up services. We can run web apps. We can create SQL databases for you in the cloud storage. We can basically build out your needs as you see fit. What is not actually implemented yet, but what is a work in progress and a place where we wish to get to fairly quickly is, for example, to be able to provide OSDU as a service in this innovation space. That means that you would then have access to all of OSDU data for all of this testing that you would then want to do or partake in. OSDU, for those who don't know, I'm guessing most of you know, is the Open Subsurface Data Universe, and it's supposed to kind of liberate subsurface data, collect, gather, and liberate it so it's available for everyone who wants who wants to have access to the data. On the side of this kind of test environment, which would be then similar to your cloud setup or VDI setup, we would also have Cegal Data Labs, for example. So Cegal Data Labs would then be this collaborative data science space, data management space, where you could utilize any type of kind of open source or closed source, by all means, resources that you have available. I'll show you and demo Cegal Data Labs in a few minutes, but for those of you who have used Anaconda, and in particular JupyterLab, will kind of be familiar with the setup here. So Cegal Labs is basically a JupyterLab setup where you have access to a fair amount of pre-installed packages. You can pip install or the packages that you would want to, and then you can build out solutions as you see fit. So I have some example usage at the bottom of the Cegal Labs pane here. So you can build data science workflows, you can write out automation workflows, you can prototype, you can build ETL pipelines. You can basically do whatever you can do, but we've created the environment for you to do your data science in. Another strength of this is that we also provide you with a way of deploying this code. So say Cegal Data Labs is a collaborative environment where it's kind of like a shared folder system where everyone can access each other's code. But if you also write code that you could then deploy, say you write an app or you write a program, whatever you want to deploy it as, we have setups that will allow you to deploy that easily. So I can just skip to the next slide, and then I'll get more back to how we would easily deploy. So Cegal Data Labs, nice little quote, is a best of breed user interface for users to build, run, and share Python notebooks with access to company data, together with a managed flexible fabric for consultants and developers to build services and execute workflows which connect to company data. So this whole data connection is kind of the main part of this. We set up a nice, easy to use environment with the data that you need available to do whatever you need to do. From an end user perspective, so for me, for example, sitting as a data scientist in Cegal and using Cegal Data Labs, Cegal Data Labs is a shared space where data scientists, engineers, and managers can run and share Python scripts and Jupyter notebooks. So I can I sit in Oslo, I can create a notebook with a workflow. I can save it in Cegal Data Lab, and then my colleague Tom in Stavanger picks it up and does the magic to it and uses it for his use case. Or he gives me feedback and tells me what I need to change, etc. It's a consistent environment where Python workflows can be published and accessible to others. So once I've kind of settled on this workflow, that's great. I can just put it in the public folder and let everyone in the company use it. Load up their data, run their data through, have a result. I can create minimum viable products and assess them easily without having to go through any type of change system. From a technical perspective, so for those of you who are interested in that, it's really just a JupyterHub environment that's deployed on Kubernetes. So it's basically a set of pre-configured Docker images that we manage, Cegal manage, and then we can deploy it either on-prem or on GeoCloud, or potentially on Azure or wherever you'd want to have it deployed. But it's an out-of-the-box environment then that you kind of just spin up and you have access to a tailored JupyterHub environment. you have a deployment pipeline using infrastructure as a service principles to quickly and easily, robustly deploy specific versions of the overall innovation space and specific applications and data sources within it. So kind of by that we mean that we allow you to access data sources. For example, in the pipeline is connecting it to, for example, OneDrive, so you can access data through OneDrive. Yeah, and other sources that would be kind of usable, feasible. You can also further utilize the platform as a place to deploy a set of services which are accessible via Keystone. So this is kind of what I alluded to when I talked about deployment. So we have a authentication system set up called Keystone, which you can set up as a gateway to this Cegal Data Labs. Then you kind of have like a tile system of applications that that a specific user is authenticated to access. And there you can also set up a lot of other services. So say that you write the web app using this Cegal Labs setup or any setup, you want to deploy that easily. We can deploy that on this Kubernetes cluster or on a Kubernetes cluster and authenticated using Keystone. So this is this is a typical setup of how it would look when you have many of these apps set up. So I don't know if you can see my cursor, but I'll go to my my cloud portal in a few minutes or a few seconds, and you'll see that I have JupyterHub set up. The idea is when you kind of build out and you use this environment as you want to use it, and you create these MVPs and you create solutions that you want to test, you can then add them as tiles in this portal setup. And by that, we'll just jump straight to my cloud portal, and I'll show you kind of how that's set up and how easily I can access this Cegal Data Labs. And just to make sure I don't ruin anything, I'll, instead of clicking the link, do this manual. So you can see this is my cloud setup. Paul showed an example of it in his talk. I have Cegal Data Labs as a tile here, so I can click that, and that launches me into this Keystone authentication page. Now I'm already logged on with my Cegal user, and I have access to JupyterHub. So this is what pops up with this single sign-on Keystone authentication. I can launch JupyterHub by clicking this, and then I'll be redirected straight into a JupyterLab setup. So for those of you knowing or who are familiar with JupyterLab, you'll feel quite familiar with this setup. So I thought I would just kind of very quickly do a super quick example of how I can take local data. So I've saved some data in a data folder here, just called Volvo Wells, and how I can combine that with data from the internet that I would want to see and combine with this data. So just first, super quickly, I've mentioned this before, but we're now authenticated with Keystone. So if software tries to access this, he's not going to be able to because he's not authenticated to see this notebook. But if he wanted to, we would add him to the system, and he can then start collaborating with us and add beautiful code. Right now, we're working on the Kubernetes cluster. So this is, even though it's, I mean, it's running on my computer, but it's really kind of separate to my computer here. Okay, we'll start. I have this CSV file here of Volvo Wells. So I'll just quickly import Pandas, which is a data analysis tool for Python, and I'll load this data up from the CSV file. So here I have a data set, and I have a bunch of different wells here. We can actually see how many different wells I have in here. Wells. Oh, I have 4, 12, 15 wells in this data set. So that's great. Then I know I have some data here. If I would like to look a bit more in detail at these wells, I'll just load a plotting package. And then I'll select one well from this data set. So I just selected the one called 59F5. I sorted the values by depth, and I set depth to index, and then I'll plot this data. I also did some magic so that my resistivity logs would show up on a log scale. So then I can easily evaluate my well logs. This is the data that I loaded. I've just exported it from Control, so it's nice to see that it plots easily in Python. But I would like to see how can I kind of take this this well data and use it with data from another source, right? That's kind of where this gets interesting, when I can use this to collate data and get some more information from it. So what I've done is that I've just gone to MPD fact pages, and then I've, well, if this opens, I just grabbed basically the list of all development wells that has been drilled. So I've just grabbed the link to this table, and I'm loading that directly into my notebook here, and I'm calling it MPD data. So that probably runs quickly. Yeah. So here I've just now, with however few seconds that took, I've loaded this data set into my Jupyter notebook. So here I have basically all development wells drilled in Norway. Yeah, since the beginning of time, 1969. I had Volvo data from my other data sets, so I'll just filter out the data from this MPD data set that's concerning Volvo. And then I would like to see how many wells or how many well names from my or from the MPD data are present in the CSV file that I loaded. So I'm not going to do too much magic there to try and match them all, but I'll just see how many are directly overlapping. So I can print that out. I can see, yeah, I have six overlapping well names from those two data sets. So just to see where those are, I've just used a package called Plotly Express, and I'm using a Mapbox to plot that on a map. I'll zoom a little bit in on this. I just wanted to show you, this is quite a detailed map. And you can kind of build very nice maps very easily using different plotting packages in Python. So we'll just zoom in here, and we'll see that we have these 6 wells that we matched from the 2 data sets plotted nicely on this map. I can take them on and off and yeah, play around with this. So that's kind of like a cool way to just easily see that you can very quickly combine data from different data sources and then create some new insights or some new visualizations that you can use in other use cases. So from this visualization, for instance, I can start building up a dashboard. I can start filtering on log types or whatever else is available for these wells. And I thought this wasn't like the coolest or most impressive map. So just for the fun of it, I also created a little map just to show the power of what you can actually do with Python when you have a system like this set up. So what I'm doing here is that I'm just taking for every well that's been development well that's been drilled in Norway, I'm taking the entry or the year of the entry date, and then I'm just gonna plot every well by year that it has been drilled, basically. So I'm just gonna play a small animation. So you can see entry year is now 1969, and then we can see how drilling spreads out over the NCS over time. So now we're at 93, 95. You see we're spreading upwards. And there we reached the Barents Sea. So this is just a super quick example of how we can start to create kind of cool and kind of less used visuals, but very quickly and very easily using Python with this setup. So that was the demo that I had for you guys. I mean, when we're kind of thinking of what we can achieve with this setup. We'll get slightly back to it in a later talk today. But basically, what this allows you, both innovation space as a total and Cegal Data Labs as a part of innovation space, is that we give you the opportunity to make things easier for yourself and to test it out and create value for your business. So by that, I conclude the talk, and now we'll see. We'll take questions if there are any questions.
Thank you very much, Hilde. It is at least one question here. If you are doing the use JupyterHub for data management, does it mean then that DM will be Python coding in the future? What will be DM in the future? Data management in the future.
Mm-hmm.
So if you're using JupyterHub for data management like you're doing here now, does that mean that data management will, do you think it will be turned more and more into scripting and Python coding like you see here for analysis?
I think that's a definite possibility. Most data management jobs, at least if you're doing cleanup jobs or if you're doing kind of asserting data quality, that can be automated. And Python is a great tool for automating that. You can easily write crawlers that would then crawl through your folder structure or your data storage, and yeah, do do whatever you want to do, filter however you want to filter, or assert that you have non-duplicate files, etc. So yeah, I think that's there's a good possibility of Python taking over part of data management. Yes. Any other questions? No. Okay, then I say thank you.
Here is one actually.
Okay.
Have you connected Jupyter with other sources like OSDU?
Jupyter is, or this Cegal Data Labs setup is not currently connected to OSDU. So we're setting up initially now a OneDrive data link, but that is a possibility. So we're kind of early on in the development of this, but that is a definite possibility. As I also mentioned, for innovation space, OSDU as a service is something that we're also working on.
There's one final here we have time for. How do you get around Python lack of speed for large volumes of data?
Good question. I mean, of course, there are some issues with that. I mean, this is a Jupyter setup, so Jupyter stands for Julia Python R. So you could also use Julia in a setup like this, actually, which also alleviates a bit of their speed issues. But then again, there are also quite a lot of good tools now for increasing speed using Python as well. You have a Dask, for instance, which you can use where you kind of utilize parallel processing as well, not just single threading. And obviously, you can you can use cloud services as well, and spin up kind of more resources and have a better machine, basically, that will allow you to process more data quickly. But yeah, I mean, it is a limitation of Python that it is fairly slow compared to competitive languages. I mean, the benefit of using Python compared to other languages, or say C++, for instance, is that it's very easy to use. So you can have more users kind of utilizing the same code potentially, or collaborating on the same code. Yeah, it's a bit of a difficult question. Yeah, Python is slower than many of its competitors. You have tools now that will make it quicker. But for kind of the heavy duty tasks, you might want to use C++ or Julia. Do that. And as I mentioned, Julia is actually you can have a Julia kernel in a hub setup. So yeah, that's one way of solving that.
Thank you very much, Hilde, for a very interesting presentation. This was very nice to learn about.